Okay. All right, here we go. So we are going to solve this equation in radians. That's what, when we say 0 to 2 pi, guys, that's radians. And that also means we're going to go all the way, we're going to look for answers all the way around, right? Okay, so here we go. So we'll start out just solving like a regular equation. So we need to subtract the 5 and divide by 4. Okay, we okay to there?
Yeah.
Now at this point, we say to ourselves, okay, the cosine is negative. Where, I'm going all the way around the whole thing, where would it be that the cosine would be negative? Yep, on the left. So my answers are going to come from over here. And the answers are going to be the pink angle, that will be the second quadrant angle, and the orange angle, which will be the third quadrant angle. Everybody on board with that? Those are going to be the answers to the question. Now, let's just pause for a second. This is not a special triangle, but let's say it was. Let's say I knew that, like that was a half, so I knew that angle right there was 60. How would I get my answers if I knew the little angle right here was 60? I would do 180 minus 60, and then the orange would be 180 plus 60, right? Now, I don't know how big that angle is, so I need my calculator, and it needs to be set in radians. I'm gonna double check. I am not, so I'm putting it in radians. And now I'm going to type second cosine 1 divided by 4. Now, I know that number's negative. What did that negative have to do with anything? That told me which quadrants to draw my picture in. Have I done that already? I don't want that negative anymore. I want to know how big is this angle right here. And as it turns out, it's 1.32. That angle is 1.32. Okay? Now, I said a minute ago 180 minus. Well, I can't do 180. I'm going to have to do pi. Pi minus. So my pink angle is pi minus 1.32. And my orange angle is pi plus 1.32. Now, guys, don't you dare be confused. When this was a 60, you told me that angle would be 180 minus 60, and you are exactly right. I am in radians, so I can't use 180, I have to use pi. So it's pi minus whatever that is. So, let's get the answers figured out here. So the actual answers will be 1.82 and 4.46. Now, if you typed in the negatives, if you type second cosine negative 1/4, you actually got this answer. What you needed to recognize is, and that's okay. But what you need to recognize is, then somehow you have to find the pink one. The orange one. You figured out the pink one was 1.82 by doing second cosine this. So then you gotta somehow figure out the orange one. And you can do that. You can subtract from 180 and get that angle, and then add that angle to 180 to get, or from pi, and figure it out. I find it easier just to leave the negative off and use my reference angles. But anyhow, those are the answers to the problem. All right, Kendall, did that make sense to you?
Yeah.
Okay. All right, anything else that you and your friends did not get sorted out? Nyla?
We did number 2 on the same quiz.
Find the cosine of 3 pi over 4?
Yeah, I don't know what I did, I just got like,
Well, I would probably change, I don't think very well in radians, so I'd probably change that into degrees. And that's the cosine of 135. 135 is over here. Has a reference angle of 45.
I figured it out.
So 1 root 2 with a negative here. So negative 1 over root 2. Yeah, we need to know how to do that. All those kinds of problems like that, because we're going to use that a lot in the next chapter. Okay? Well, that was quiz number 1. We're going to have another quiz our next class. So, is that tomorrow, I believe? Yesterday, or last time, we practiced quick review number 3. You remember that? We did. We practiced it. So what we're going to do today is practice some more problems that are just like that. And that's what's going to be on tomorrow's quiz. There's a lot of material in this chapter. That's why I gave a review quiz over part of it. Now we're working on this other part. So we put it all together and take a test next week. Okay, so here we go. Would you find in your review packet that I gave you, this thing right here, this review packet that I gave you, would you find the one that is called Practice Test 4? Practice Test 4. Now we're going to do as much of this as we can, but I want to start with the problems preparing us for tomorrow's quiz. Okay? So we'll go through and do those so you know exactly tomorrow's quiz is review number 3, quick review number 3 that we did last time, and then these problems. Alright, so here we go. So I'm picking and choosing, and then we'll go back and do whatever you want to do. But 1B says find the exact value. What does that mean? We're not typing it in on our calculator. Could we? Absolutely. But we're not going to. We want the exact value. So who remembers how this goes? We practiced one the other day. Jake?
Have to set it up right at the tan, which is in quadrant 1, so it's positive.
Perfect. Stop right there. Jake says, I'm going to set this up with my little triangle. I know that it's in quadrant 1 because that number's positive, and anytime that number's positive and I'm using my inverse notation, I know I'm in quadrant 1. What are the rules for the negatives? Who remembers? If it's a tangent or a sine and it's negative, it's in quadrant 4. If it's a cosine and it's negative, it's in quadrant 2. But this is positive, so it's in 1. And here's your angle right here. And the tangent is opposite over adjacent. Now what? Find the third side. This happens to be a pretty common Pythagorean triple, but you would do the Pythagorean theorem, right, to find it. This one's 5. So there's a picture of that angle. Now, what do I want to know about that angle? I want to know its sine. Well, the sine of that angle is 4/5. Now, the numbers aren't always going to be so lovely. Do you understand it's possible to get a radical here, obviously, if I'm doing the Pythagorean theorem? So my answer may not be pretty like that. It might be, 4 over root 17 or something like that. Got it? All right, next one, same section, letter E. Letter E. This is kind of like the one Nyla asked about. We want to find the exact cosecant of 3 pi over 2. Well, what's 3 pi over 2? 270. And what's special about 270? It's what we call quadrantal. It's actually right down here. Right? And when it's down there like that, I can't draw a triangle. Well, I can't draw a triangle, so I do draw a circle with a radius of 1, called the unit circle. And that point right there would be then 0, -1. And I need the cosecant. What's cosecant? Reciprocal of sine. What's my circular definition for sine? Sine equals y over r. So cosecant is going to be r over y. So here we go. R over y. The answer to the problem is -1. All right, now number 2. Okay, a multi-part question. Is it sinusoid, or find the period, is it sinusoidal, why or why not?
No, it's not.
All right, so let's look at this part of the problem. What is the period of just this chunk?
2 pi over 3.
2 pi over 3. The standard normal period of sines and cosines is 2 pi. This number divides that period, so it's going to be 2 pi over 3. What's the period of this one? Pi. Since these are not the same number, it is not sinusoidal because they aren't the same number. So the y part of that is they're not the same period. This is a periodic thing though. It does have a period. And its period is going to be the first time that both curves are starting over at the same place. So this one is starting over every 2/3. So at 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, and so on. This one is starting over every pi. The first number that's in both lists is the period of the function. Is that 2 pi? So the period of your function is 2 pi. Anybody have a question about that?
Is it ever not going to be 2 pi?
Oh, yeah.
Yeah?
Yeah, I think there was one in your homework that wasn't 2 pi.
Really?
I think so.
Okay.
Yeah. Now, is it frequently 2 pi? Yes, because 2 pi is just a special number in sine and cosine land. But yeah, it doesn't have to be 2 pi. All right, number 4. Find a negative coterminal angle for negative pi over 7. Now, how do we find coterminal angles? Add or subtract revolutions. And if I'm in radians, that's 2 pi. That is right. So Abe says, if I want a coterminal angle, I'm either going to add 2 pi or I'm going to subtract 2 pi. Since the problem specifies a negative, won't it have to be this one?
Yeah.
So that's negative pi over 7 minus 14 pi over 7, get a common denominator. So our negative coterminal angle is negative 15 pi over 7. If I were doing the problem in degrees, I would do exactly the same thing, only instead of adding 2 pi, I would add 3/16, or subtract 3/16.
Would you have to get the other, the pi, negative pi over 7 into the degrees before you do that?
No, because you're gonna answer this question, Jake, in whatever form it's given. So
Okay.
this was a radian angle to start with, so
Yeah.
I'm gonna answer it in radians.
And
If it were a
you do-
degree problem, it would say something like 15 degrees.
Okay.
Yeah, we're not gonna be changing in this case. You'd have to change back, and that's just a waste of time. All right, everybody okay with that? Number 5. In which quadrant do I have a sine that's greater than 0 and a cosine that is less than 0? Which quadrant does that happen? Please remember, greater than 0, and this sounds goofy, but we mess this up sometimes. Cosine, or greater than 0 means positive. Less than 0 means negative. Where is it in the coordinate plane that sine is positive, but cosine is negative? I heard somebody say 2, and I agree 100%. If you look at a triangle in quadrant 2, will opposite over hypotenuse be positive? But adjacent over hypotenuse will be negative. Now, another way to think about this, and it's up to you, this is, I don't know how you got quadrant 2, you're right, it is quadrant 2. A way to think about it is, sine is associated with which coordinate, x or y? Y. Cosine is associated with x. So basically what this problem is asking is, where is y positive and x negative? Well, that's quadrant 2. Okay? All right, next, number 10. Write the equation of a sine and cosine function. So you've been given the picture. And you are going to write the equation of a sine curve and a cosine curve. And I'm putting all the, you don't have to set it up this way, I'm putting all these blanks in here because in the equations of trig functions, there are 4 places where numbers can happen. We may or may not need all these blanks. Okay, so which one do you want to start with? I think that's a sine or a cosine. All right, we'll start with sine. Do I know what that vertical is for? If it's a sine, then it literally is starting right here. There's my hill and there's my valley, right? So if I'm looking at it as a sine, one option would be that orange curve right there. Okay. What's the amplitude of that curve? 4. And that's a positive 4 because I have my hill first. If I were looking at this part, I would have my valley first and that would be negative, but I'm looking at that orange part. Okay, do I have a phase shift? Is there something that goes here if that's a sine curve? Plus pi over 6, right? Because it went left. Does it have a vertical shift? Nope, going up up 4 and down 4. If it had a shift, it would like go up to 6 and down to -2 or something like that. So there's no vertical shift. Now, this number is the one that always gives us fits. And it shouldn't, because you know that the period of a sign is supposed to be 2 pi. But when you stick a number in there, that changes your period to this, 2 pi divided by that number. Well, look at your picture. Tell me what your period is. How far is it from -1/6 to +3/6? -1/6, +3/6. How far is that? 4/6? Or 2/3, I'm just gonna leave it 4/6. 4/6 pi? That's my period. That's how far it is from here to here. Right? Now figure out what the number has to be then. So I'll just cross multiply. 12 pi divided by 4 pi is just 3. And there it is.
Where did you get the 3/6? Is that,
1/2.
oh, so you said equal, this pi, okay. Gotcha.
So I said this was a 6, I made
Yeah.
this a
And
6 so I
it's
could
3
measure.
pi over 6.
Huh?
Is it 3 pi over 6?
That is 3 pi over 6. The period is 4 pi over 6 because it started back 1.
So why is it pi over 3?
It could be 2 pi over 6. It can be 2 pi over 6. Reducing fractions,
Yeah.
but you don't have to reduce them like when you're doing it yourself. So that's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. I just reduced it because I was putting it in writing. Okay, all right, here we go. Now, what if we look at this as a cosine? Well, one option would be to look at this right here, wouldn't it? Wouldn't that be one option?
Yeah.
There are other options. You need one option. Pick one. That would be a positive cosine. The period and the vertical shift are exactly the same. You haven't changed that. The thing that has changed is now you're starting here, which is where you're supposed to start, which means there is no horizontal shift for the pink picture.
So it has the same period as mine.
Yes, it's the same curve. We didn't redraw the curve, it's the same thing, we're just doing a different piece of it. Okay? If you go back and look at review, or that quick review number 3, you will notice that the problems we just did are like those. Now you're all sitting there so nicely, wonderful. I'm gonna give you a paper next time that's gonna have these problems on it. And I'm hoping that the results are a little better than they were for the last one. So one thing I think that will help us is we can actually do math outside of class. You know, like you can actually go home and study, practice, redo the problems, maybe copy them on another sheet of paper and work through them. And all this is on video. So if you're like, hey, I can't remember how she did this, you can always just bring me up, watch me at home. Okay? All right. Okay, now, that is our quiz tomorrow. We are having a test next, I put it in Power School and Schoology, I think it's Tuesday maybe, I can't remember, sometime soon we have a test. So, I want you to look at practice test 4, I picked and chose, I took the ones that I knew were gonna be on our quiz. But all this is called practice test because it's like your test. So all this is on the test. Look at it. What do we need to practice? We're gonna use every single minute of this period to review. So you tell me what we need to practice. Okay, so I'm just gonna pull one off another practice thing. Okay, so she wants to do another one where we have to write the equations, which I will gladly do. I don't wanna use, well, I guess we can, but we don't have to confine ourselves to just these problems that are on tomorrow's quiz. We need to review for the whole chapter. Here's one. I didn't reduce these fractions, Kamara, just read it.
Thank you.
Okay. All right, we're gonna write a sine equation and a cosine equation for this. Now, what do you notice about this guy right off the bat? There is a vertical shift. So to kind of help myself, I think I'm going to put in my new axis. Does that make sense to you, that that would be the axis now that it's oscillating across?
Yeah.
And where is that axis? What's this label right here? 4? So that means that my picture has moved up 4. Does that make sense to everybody? It also shows me that my amplitude is what? How high are these hills and valleys? 2. So my amplitude is going to be 2. Now, would you agree, and I don't know, I kind of just like to start at the beginning. Would you agree that this is one period? That's a period of it. And if I look at that particular period, it's a sine, and actually it's upside down because the valley comes first. And it's starting, if I start there, it's starting at negative 2 pi over 8. So this will be plus 2 pi over 8. Now, I think I told you before, these problems are grading nightmares. Because could I have made a sine curve that started here?
Yep.
Yeah? Could I have made a sine curve that started here?
Yep.
Yeah, there's lots of them. There's lots of them. Okay, your answer may not be what I'm writing on the board, but it still could be right, because there's lots of sine curves out there. Okay, now I need my period. All right, what's the period of a sine curve supposed to be? 2 pi. But I've altered it, I've divided it by something to get this new period, which is what? From negative 2/8 to positive 2/8 is a total of half a pi, 4/8, half a pi. I'm gonna leave it 4/8 so there's no confusion with anybody, but pi over 2 is fine. Same thing. Negative 2 to positive 2. So 16 pi equals 4 pi n, so it looks like, is n 4?
Yeah.
So this is going to be a 4. Now, if it's a cosine, it can't start there. Could it start here if it's a cosine? Yep. It could start lots of other places, but a cosine, remember, has to start at the top of a hill or the bottom of a valley. So I just picked to start here, which means my cosine is also negative. And its phase shift is just negative pi over 8, so it's gonna be plus pi over 8. And everything else stays exactly the same. Okay, Sydney? All right, do you see anything else on the practice test 4? Do you see anything else there? Kara?
Number 8.
Number 8. Now this is kind of the opposite of what we just did. This is, here's your equation, and you are going to sketch it. All right, so it's a cosine. I know what cosines look like. It's a positive cosine. So it's gonna have that shape. But what does this do? Shifts it to the right. So I'm gonna have that shape, but it's going to be starting at pi over 8. I know the amplitude is 2, and there is no vertical shift, right? There's no number on the end, so I don't have any vertical shift. I have to figure out what my period is. So I know my period is normally 2 pi, but I have divided it by a half. So my period this time is actually 4 pi. 2 pi divided by 1/2, 2 pi times 2. Which means that from here to here is 4 pi. Now, 4 pi is 32/8. Would you agree with that? So I'm gonna start at 1/8 and add 32/8. So I'm gonna be at 33/8. That's where I'm gonna stop drawing, at 33/8. Why what? Period is distance from beginning to end. Right in the middle of 1 and 33 is what? Well, 1 and 33 is 34, divided by 2 is 17. So this is 17/8. Midpoint, average, add and divide by 2. 1 and 17 makes 18, and half of that is 9. 17 and 33 makes 50, and half of that's 25. All right, so Kara, there's the picture. You good with that? Now we have to write down everything. We already did the period. So the frequency will be the reciprocal of that, 1/4 pi. Amplitude is 2. Phase shift is positive pi over 8, or right pi over 8, and there is vertical shift is 0. Everybody good on that?
Yeah.
All right, tell me, what else? Practice test 4. Yes, Drew?
Can we do 13C on the page before that?
I really wanted to stick to this.
That's fine.
Yeah, let's stick to this sheet right here, and then we'll do that if we have time tomorrow, okay? Let's stick with this sheet today. Abe?
Will we have to know tangent
drafts tomorrow?
For the quiz tomorrow, no. And the only thing, I mean, you need to know how to graph a tangent for your test, yes, but for the quiz, no. On the quiz, you're not even graphing tomorrow. On the quiz, you're just taking an equation or a picture that's already done and writing it. Are you responsible for knowing how to graph a tangent? Yes, you are. So a tangent graph, I don't know, let's just say 3 tan 2x. Okay? So this is like Kara's question, when hers was a cosine. You're graphing this, so it's good to know what the basic shape is. And it's good to know what the basic period is. For a tangent, guys, the period is not 2 pi. Sine and cosines are 2 pi. Tangent, the period is pi. So when you stick this 2 in here, now the period is pi over 2. And that means that from asymptote to asymptote is pi over 2. That's a period. So what would these asymptotes have to be? If the whole thing is a half a pi, then what are these gonna be?
Quarter pi.
Our quarter pi, negative and positive. That's right, that's how you're gonna get a total of a half. Is that okay? All right, what else? On this practice test, please look at it. Tell me, what do we need to practice again? Oh, wait, number 9 was the tangent. Let's do number 9. I didn't see it on there. Number 9 says graph that. So we'll just get a little practice, extra practice here. So negative tan 5x. What does the negative do, guys? What does the negative do? Flips it. So this one is going to have this shape. Upside down. What's the period of a tangent is supposed to be pi. This one has been divided by 5. Now a huge mistake, or I should say huge, a common mistake I see is kids will put pi over 5 and negative pi over 5. That's not right, because this distance has to be pi over 5, which means this distance has to be half of that.
Yeah.
So this is 1/10 and negative 1/10. Does that make sense to everyone?
Yeah.
Remember, tangents never have amplitude. So even when there's a number stuck out in front, when there's a blank that says what's the amplitude, there's none. None. That 3 will change the curvature, but there is no amplitude, there's no height. All right, what else on this page? Yeah, Kara? Huh? 13. Okay, this is another equation like we had at the beginning of the period. We were solving an equation. This one is in degrees because of those directions. So let's see, 3 sine equals 2, sine equals 2/3. Okay, is that all right, Kara? Go into there, sine 2/3. Subtract 5, divide by 3. Now, I'm going to use my calculator. I'm going to need to use my calculator. But before I go to my calculator, I'm going to figure out where my answers are going to be. Because your calculator is not going to give you the full picture. You need to know ahead of time where are you looking at your angles being. Sine positive, where is that? 1 for sure. And 2. Sine is y, guys, sine is y. Where's y positive? Quadrant 2 and 1. Okay? Now, you can go ahead and label this if you want 2 and 3. You can even find this side if you want, but this is not special. Your job is to figure out this angle, right? So I'm gonna go to my calculator, set it in degrees now, back to degrees. And second sine 2/3. I got 41.8. Did you get 41.8? Now, sometimes 41.8 won't even be an answer, depending on which quadrant you're in. But because I'm in quadrant 1, isn't one answer 41.8? How am I gonna get the other answer, which remember, starts here at 0 and goes all the way to here? How am I gonna find that one? 180 minus 41.8, which is 138.2. Double check that arithmetic. Okay? Now, that could be a radian problem, and we would do everything exactly the same, except this would come out being like point something, and instead of subtracting from 180, we'd subtract from pi. No difference. Max,
So why are there two
why are there two?
triangles? Yeah.
Because all the equation says that there's some angle out there that has a positive sign.
Oh, that's the two positives.
And these are the places where the sign can be positive. All right, we have time for one more. Let's do one more good problem, and then I'll shut up, okay? Come on, hang with me here, one more.
Can we
Man,
use 7?
7. 7. This was actually on the quiz that we already took, but it is definitely on the test also. So we need to get this figured out. First one says, if the radius is 8 and the angle is 100, find the arc length. So remember, Van and everyone else, arc length is simply the radius times the angle. That's it, it's radius times angle. But the problem is, the angle has to be in radians. So I'm gonna take this angle and I'm gonna change it into radians. So pi is to 180 as x is to 100. So 100 pi over 180 is 5 pi over 9. So Van, what I have just done is simply change my degree angle into a radian. Now, arc length is simple. It's the radius times the radian measure of the angle. So that will be 40 pi over 9. Inches, or whatever the unit on the radius was, that will be the arc length.
We have to find the area on our test.
You have to do everything on here. So he says, find the area of the smaller sector. So when you drew this picture, you actually split the pie up into two pieces. The little piece and the big piece. And this says, what's the area of the smaller piece? So in other words, what's this area? Well, what's the area of the whole circle? The whole circle is 64 pi. I want 100 3/60ths of it, don't I? I want this fraction of that. So let's see, that's 5/18 times 64 pi. This reduces, let's not get all hung up on the arithmetic. I got 160 pi over 9. I think I did that right.
Yeah, that's right.
But Van, the moral of the story is if you want area, you know what your angle is. So it's that piece of 360, so 100 3/60ths of the whole thing. Okay? And then it says find the area of the larger sector. So that's this out here. For me, the easiest thing will be to take the total area and subtract the one I just found. Would that do it? That would be one strategy. You could also say, well, if that angle's 100, this one is 260, and you could do 260 over 360 times 64.5. Either way, you'll get the same answer, either way.
So, what's the say?
If that 164.5, yeah, that's one option. All right, now, I liked what Drew was doing. For some reason, he was looking through the rest of these pages, and he found a problem he wanted to do. That's what I want all of you to do, is spend some time looking through here, so that after our quiz tomorrow, you have something to review.